Hey guys, it's Campbell here. Today we're going to be discussing how we might code a basic Clawbot robot. Now there is a Clawbot that Vex publishes the instructions for. Hopefully I just flashed it on the screen. Many teams often employ a very similar design to this because it's a fairly simple robot, generally a 2-motor or 4-motor base with a 1-motor arm and a 1-motor claw. So this code only needs to accomplish a few tasks. This robot needs to drive, it needs to raise and lower the arm, and open and close the claw. This is one of the most simple designs that we can employ in competition robotics. I previously made a video on coding a drive base. If that is something you are interested in covering in more depth, please check out that video, because right now I'm only going to do a short recap. So if you want to skip this recap, go to the timestamp on the screen. So recall that we can set a variable speed for our drive base motors, meaning we can make it go slower or faster if we want to, sort of like the gas pedal in a car. We can accomplish this by setting the motor speed percentage equal to the position of the axis that we want to control our base. So generally people use axis 3 to control the forward and reverse movement. So we can set our individual motor speed, which is what I have, or if you're using a drivetrain, your drivetrain speed equal to the axis 3 position as a percent. Now if we want to use axis 1, people generally use axis 1. You can use whichever you want, I suppose. You could use axis 4. But if we want to use axis 1 to control our turning or our rotation, all we do is simply add or subtract the position of that axis to the position of axis 3 and set the sum or difference of the values to be our base speed. And recall that this is because if you put axis 3 all the way forward, the axis position is 100, and if you put axis 1 all the way to the right, that position is 100. And so you will want to turn the robot right, which means your left wheels will be spinning forward and your right wheels will be spinning in reverse or will be stopped. And so sort of the same logic but flipped when you're turning left. When axis 1 is all the way to the left, it's negative 100. So if you've got axis 3 pushed a little bit forward, then you've got the left motors being positive but minus the value of axis 1, which is going to be a lot more negative than it is positive. I hope that makes sense. Alright, anyway, so now that we have our base coded, we can start working on the arm. So the arm is going to be really simple, since all it needs to do is go up or down. So first, let's do what we should always do in programming. Let's think through or write out the process that we think we need in order to accomplish this task. So let's think about this. We need our arm to do one of 3 things, depending on the input from the controller, right? We either want the arm to go up, to go down, or to not move. So our code skeleton, or our diagram, should look something like this, right? Right, we have this input, we want our arm to go up. If we have this input, we want our arm to go down. Otherwise, we want our arm to stop. So it looks like we can accomplish this with a simple if-else statement, right? Where we've got if input, then the arm needs to spin forward. Else if other input, the arm needs to go down. Otherwise, the arm needs to stop. Now I like to use the left triggers for arms, so let's go ahead and go back to our code here. So we will go to control, we will grab a big if block like this, if, else if, and else. And we will go to sensing. So remember we want to use our triggers, so we've got controller 1 and we want L1, right? So if L1 is pressed, then we want to spin our arm motor forward. In this case, we'll just say that forward is up. Otherwise, if we've got our L2 pressed, then we want to spin our arm motor reverse, right? Otherwise, we want to stop that motor. And this should be all we need, so we put that in our forever block during drive control. And now, whenever we turn our robot on, we press L1, our arm is going to go up. We press L2, our arm is going to go down. Otherwise, it is going to stop. Now, there's one more thing that you should consider when you have an arm like this. Not necessarily only if you have a Clawbot, but if you have any type of arm for any purpose, you might be able to apply this. So when your motor stops, you can set different stopping types. So right here, you see this block, set motor 1, stopping type 2, and you've got these 3. So your stopping type is automatically set to coast. What that means is that when your motors are not receiving an input to spin, they will sort of free spin. If you're familiar, this is sort of like putting your car in neutral. If your robot was on a hill and your base motors were set to coast, your robot would roll down the hill. This also means that if your robot was on a flat surface and traveling very quickly, when you let off the gas, when you no longer give the input to have your robot go forward, your robot's momentum would cause it to keep moving forward until friction slows it down. The other 2 stopping types are brake, this one right here, and hold, as you can see. So brake means that the motor will stop immediately when no input is given, but not enough of a holding force will be applied to keep the motors where they are. For example, if you had an arm motor set to brake and you raise the arm, as soon as you stop raising the arm, all power is shut off. Even if the arm moved quickly and had momentum, it would not move any farther upward. But the arm will not stay where it was because not enough force was applied, so the arm would fall back down. Hold means that when the motor is stopped, a strong force is applied to keep the motor in the exact position it was when the input stopped. If your base motors were set to hold, your robot would stop quickly, and if you tried to push your robot around on the field, its wheels would resist turning. If your arm motor was set to hold, you raise the arm up. Whenever you let go of whatever the button it is that raises your arm, the arm would immediately stop, but it will resist falling down. So you can set your arm motor to be whatever stopping type you need it, and set it wherever in the code. Ideally, you'd put it like up here or before the loop, where I want my arm motor stopping at brake. Perfect. Or I want it to hold. All right. So if my explanation was a little confusing, I apologize for that. I've linked a video in the description by, I think it's pronounced Skid Kelly. Apologies if I butchered that pronunciation, which gives visual explanations with a Clawbot. It's a great video, so if you want to check it out, please go do so. Now finally we can code our claw. Remember that the claw only needs to open or close, so this code segment will be highly similar to our arm code. I will use the right triggers for the claw, so R1 will open the claw, R2 will close the claw, and I'll just use another simple if-else statement. So I'll go back to control, I'll grab this block. Instead of it being L1 this time, we want R1. So R1 is pressed. We want to spin our claw motor. We'll say that forward is closing it. Or did I say opening? Whatever it is. We'll say that forward is opening the claw. And then I'll say that R2 is to close the claw. And we'll say that spinning reverse is closing the claw. Otherwise, we want to stop that motor. And that should be it. And once again, if you want to set the stopping type for your claw motor, if you want your claw to hold shut and not budge, you'll want to set that to hold. If you want it to be coast, where you grab something and you need to hold it closed, but when you let go, friction might hold the object up, or your claw might open. Whatever you need it to do, go ahead and set that. But this is all we need for a simple Clawbot. Just 3 little code segments to move the wheels, move the arm, and move the claw. So if you have a Clawbot or a Clawbot style design, keep in mind that you can absolutely make your code more complex than this. If you have a particular idea to improve on the basic Clawbot or what have you. But let me know if there's anything else that you guys want me to cover. Leave a comment if you have any questions about this. And if you found this video useful, please consider leaving a like and subscribing. Channel statistics show that 94% of my viewers are not subscribed, so if you enjoy this content and you find it useful, please consider subscribing. It would help me out a lot. And thanks again for watching. I will see you guys next time. Bye.